Welcome to our conversation about fingerprints. So to understand where we are now, we'll look at where the historical development has come from, and it goes back to actually 3rd century BC in China, oldest known documents about fingerprints, and then also shows back up in ancient Babylon as fingerprints were pressed into clay tablets as contracts. Fast forward to the year 1684, and there was a doctor whose paper describes the pattern on human hands, as well as the word ridges. And then 1788, noticing the arrangement of skin ridges is never duplicated in two persons, and that's a very important discovery. And then in 1856, the understanding that fingerprints are not altered with age, so they stay consistent throughout your life. Also an important thing for forensic science use. Okay, 1883, a guy named Alphonse Bertillon created a way to identify criminals that were repeat offenders. You know what? This was kind of a step in the wrong direction. There's something called the Bertillon system, which used body measurements, like, for example, wingspan, the dimensions of the face, to try to identify a human. And this sort of came to a head when two guys were mixed up in a prison, Will West and William West, and they looked very similar. You can check it out on the content page, but that really kind of disproved the Bertillon system, moving us toward the direction of fingerprints once again. There is a technique of fingerprint classification system still used today that was created in 1888 by Galton and Sir Edmund Richard Henry. And then 1896, devising a system to divide fingerprints into groups, which we'll look at today, and then recording prints for a person on a 10-print card. This is an example of a 10-print card, so it's a systematic way of rolling an inked print onto the same piece of paper for all 10 prints. The reason that you roll is that there are ridges. If you look at your finger, there are ridges on the side of your finger as well, not just on the pad. And so if you get a lot of those ridges, then you have more detail you can go by. What are fingerprints? Well, not only are your fingers covered with them, but also your toes, feet, and your palms. If you've never looked at your toe prints, I'm going to ask you to take your shoes off right now, wherever you are, and I want you to look at your toe prints. Your toe prints actually have similar ridge patterns as your fingerprints. And so these are ridges that are arranged in connected units. They can also be called dermal or friction ridges. And our fingers, especially when you're cold, your fingers don't deposit as good of prints as they will if you're warmer. You have sweat, natural oil secretions, you pick up dirt or oils from things that you touch, and those deposits along the ridges of our fingers are what leave our fingerprints. So let's take a look at the cross-section of the skin. We looked at this some when we were studying hair, but we've got the inner layer called the dermis, this light pink layer, the outer layer called the epidermis, and in between those layers is something called the basal layer. And here is a cool thing. I didn't know why fingerprints formed at first when I first began studying this, and this physiologically makes sense. The basal layer between the dermal and epidermal layers grows faster in a person's development than those two tissue layers. And you can imagine that if one small layer in between is growing faster, then you're going to have this bunching up or wrinkling. And that collapse and fold is actually what forms the intricate shapes of our fingerprints. The other amazing thing is that this happens at 10 weeks in utero. This is when the fetus is just about 3 inches long, and already at that point the fingerprints are developing. Even identical twins have unique fingerprints, and this is believed to be because fingerprints have some of their origins in the environment, in the amniotic sac. So let's say that identical twins are in the same amniotic sac. One of them has their fingers on the other one's head, and the other one has their finger kind of pushing against the side of the amniotic sac, and that movement and that pressure helps to decide the form of those ridges that will grow. So there are 3 basic fingerprint distinctions. There's the arch, in which the ridges move in and out in the same direction, or I should say in different directions across the page. A whorl, where you have one or more ridges that are encircling, and a loop, where you have one or more ridges that are entering and exiting on the same side. Arches, about 5% of the population. Whorls, about 30%, and loops, the most common, at about 65% of the population. So we can further divide each of those into some subcategories. The arches are divided into a plain arch, which is more of this kind of rounded hill, and the tented arch is more spiky, and the tented arch is a little less common, 1% of the population. Also whorl patterns. A central pocket is 2%, I'll show you one of those in a minute. A double loop whorl is 4%, and an accidental is 0.01% of the population. So since we were just talking about whorls, we'll jump to that. The central pocket loop is a type of whorl, and so you see that it has the circle forming here. The trick is that if you find the deltas are kind of tucked away under that whorl, and that's called a central pocket. I think of it like it's in the pocket, it's away from the main part. A plain whorl, as you see here labeled whorl, if you were to draw a line between the deltas are these triangles, you can see that you are intersecting some lines that are encircling here, and that defines a plain whorl. Okay, and then the other ones that you see here, plain arch, tinted arch we talked about, a loop, two different directions here, we'll define those in a moment, and then our double loop whorl, and our accidental, which is just 0.01% of the population. Okay, let's zoom in on arches, and we're going to take the time to be able to create a 10-print card for you, but during this video I'd like for you to pause it at different times and just kind of look at your own fingerprints and see what you might have. So we'll talk about the three and then I'll invite you to do that. Arches, simplest type, formed by ridges that enter on one side of the print and exit on the other. And there are no deltas, no triangular shaped ridge patterns. So we've got a plain and a tinted. Loops must have one delta and one or more ridges that enter or leave on the same side. So here's our delta right here on this one, and here's our delta on this one right over here. And so that's called a recurving ridge. It enters and exits on the same side. Now, one of the ways that we use to distinguish a type of loop is if I'm looking at this deposited print, I'm going to say that's a left slant loop because it's entering and exiting back on the left. This one is going to be a right slant loop. One of the other ways to classify loops is radial and ulnar. And so you'll remember that when you go to shake someone's hand, your radius is on the top, your ulna is on the bottom. So this is your radius, this is your ulna. Now, if you think about, I'm putting my hand down on paper. Okay, this is my right hand, I'm putting it down on paper. If those loops curve in this direction, okay, this direction, it's going toward my ulna. Therefore, it is an ulnar loop. If those curves are curving this direction toward my radius, then that's a radial loop. So put your hand kind of down on a table or paper and think about which way is it curving. If it's curving toward your radius, it's radial. Toward your ulna, it's an ulnar loop. Okay, and the last main distinction is the whorl. Whorls have at least one ridge that makes or tends to make a complete circuit. They also have at least two deltas. And if a print has more than two deltas, it's probably accidental. So uncommon though. So here's that plain whorl we were talking about. The line between the two deltas intersects some of the circular lines. That's a plain whorl, and that's a little more common. Central pocket whorl, the line from delta to delta, let's see, where's that second delta? Right in here, does not intersect the circles, and so that's a central pocket whorl. Okay. And then these are more of the exceptions here. The double loop whorl is just 4% of the population, and notice we have our two deltas here, and it's as though we have two loops. Here's a line of recurve, and then here's a line of recurve. It's still classified as a whorl, however. And then accidental whirls are just 0.01% of the population, which is 1 in 10,000 people. If the population would have an accidental whirl, or 1 in 10,000 of all the prints that exist out there. So accidentals basically have usually 3 deltas, and they're just kind of miscellaneous. They don't really fit into any other category. Alright, time for a quick quiz. I would like for you to take a look at these 5 prints, and I'd like for you to jot down what you think they are. So please go ahead and pause your video now. Okay, so let's see how you did. If you said that A is a plane whirl, then you're right, because if you draw that line from delta to delta, you see that those lines of encirclement are intersecting. That's a plane whirl. B is a double loop whirl. You can see lines of recurve coming in and out here, as well as in and out here. So that's a double loop whirl. Again, 4% of the population. C is, did you say tinted arch? It's not. I see that spike, but look, there are lines of recurve coming in and out, and so I would call that if this is your right hand, I'd call that a left slant loop, or in other words, a radial loop. Okay, D, this one is a tinted arch, and then E is a plane arch. Alright, so examiners not only look for the classification of fingerprints, but also much deeper than that in terms of, so classification would be first level detail. Second level detail would include minutia points. For example, the core, where the center of the loop or whirl exists, the deltas, which we've talked about, and then the ridge counts, the number of ridges between core and delta. Okay, here's just another look at the deltas among the different types of whirls. And then again, plain arch, tinted arch, no deltas. Alright, these are the minutia patterns, or the second level of detail beyond just the first level of classification. So we've got an ending ridge where the ridge just ends. A bifurcation is a big deal where it splits in 2, island ridge, dot, bridge. Okay, spur or hook, an eye or enclosure, kind of like a bubble. Double bifurcation, again a delta, and a trifurcation. Those are the 10 minutia points. And then beyond that, there's a third level of detail, which would be like creases or scars that exist in that person's prints. Now, there are 3 types of prints. Patent, which means they're visible to the naked eye without processing. This could be that somebody puts their hand in avocado and puts it on the table, and you can see that. Plastic would be indentations. For example, someone puts their hand in dust or clay, wax, or soap, and it leaves a plastic print. Latent is that they are invisible until they are processed by powders or other chemicals. There are several ways to process. Fluorescent powder is one of them. Here I am working with one of our Forsyth crime scene investigators, and I was spraying a fluorescent dye on a cyanoacrylate processed print on this jar. Here are the ways to process prints. So let's say you've already dusted, and now you've got to try to make it visible, or maybe you haven't already dusted. Maybe there were latent prints that were very hard to see. So you're dealing with paper. Ninhydrin would be something you would use. Cyanoacrylate is good for fuming or processing these types of items: plastic, metal, glass, also skin. Silver nitrate, wood, and styrofoam, and then iodine fuming, good for these products here. I would invite you to go ahead and pause your screen now and take a closer look. Ninhydrin, again, the purple-blue would be the processing for that. Cyanoacrylate is going to show up as a white print, and we're going to take a closer look at this fuming in class as well. And then here's some facts. Can they be erased? Yes, but only temporarily. Temporarily, they will grow back if removed with chemicals. Is it reliable? Yes, but analysts can make mistakes. And computers, oh, sorry CSI fans, can make a match not in seconds, but in 2 hours. New scanning technologies include biometrics, looking at the face, veins, eyes. That's kind of areas of the future. And I'll say thanks so much for joining in. And there are 2 summary pages here, so you can take a close look.